Hi everyone, in this video we'll discuss specular reflection model and Pohm model. In the previous video we have seen the definition of light, the properties of light and the equation for diffuse reflection. Right, we know what is diffuse reflection. When light falls on a rough surface, it gets scattered equally in all directions, known as diffuse reflection. And we have seen in the previous video, in addition to this diffuse reflection, we have spotlight or focus light known as specular reflection, right? And how this specular reflection occurs is the total intensity of light or near to the total intensity of light when it is concentrated on a specific region or when it is focused on a specific region, we'll get specular reflection. And we know in specular reflection angle equals to the angle of incident light. And this is the diagram for specular reflection. It has four vectors. L is the light source and N is the normal vector to the surface and R is the reflected light and U is the direction of view. And theta is the viewing angle relative to specular reflection direction R. Right, and for this, to find out the intensity of specular reflection, we use a Pohm model. And this Pohm model sets the intensity of specular reflection proportional to cos ns phi. And ns is the parameter that is used to determine the type of the surface. Right? And this phi, it should be in the range from 0 to 90 degrees so that we'll get the value of cos from 0 to 1. And for a shiny surface, this ns value should be very high, should be either 100 or above 100. And for the dull surface, it should be near down to 1. And for a perfect reflector, this ns value, it should be equal to infinity. Right? And we have seen Pohm model sets the intensity of specular reflection proportional to cos phi. Right, proportional to cos phi, and since it is proportional, we are supposed to include a constant. Right, so I'll include a constant W theta, which is for monochromatic specular intensity variation. Right, and now I'll write the Pohm equation for specular reflection. Intensity of specular reflection, which is equal to the constant, and I is the intensity of the point light source, which is into cos ns phi. This is the Pohm equation for specular reflection. Now, if I consider, right, in the diagram, if I consider this B which is the direction of view, and R is the reflected light, both if I consider as unit vectors, instead of writing cos phi, I can write V dot R. Right, I can write V dot R. So this Pohm equation for specular reflection, it becomes I spec is equal to constant intensity of the point light source. In the place of cos phi, I'll be writing V dot R and this ns parameter. Right. Now if I write the simplified Pohm model by including a halfway vector I have included between L and V. Right, for if I include a halfway vector between L and V, right, instead of writing V dot R, right, now this alpha is the angle between N and H. In the place of V dot R, I am supposed to write N dot H. Right, I am supposed to write N dot H. So in the Pohm equation, V dot R will be replaced by N dot H, and cos theta will be replaced, cos phi will be replaced by cos alpha. Where do I get this cos alpha? The angle between N and H will be alpha. Right, V dot R is replaced with N dot H and phi is replaced with alpha. Right. Now, in the previous video, we have learned the equation for diffuse reflection. Right. Now, specular reflection, intensity for specular reflection, I have written with the Pohm equation. To this specular reflection, if I combine the diffuse reflection, the equation what we have learned in the last video, if I combine both the equation, I'll get the final equation as KAIA plus this diffuse equation plus this specular equation. This Ks is the constant intensity of point light source n dot h. How do I get this n dot h? By including a half-wave vector between L and V, and this ns is a parameter. Right, this is the total intensity including specular and diffuse. Right, now this equation is for a single light source. Right, if I want n number of light source, I have to do the summation of all the light sources. Right, my equation becomes, right, this sigma is for summing of all the light sources. And here I have a bond model. Right, this bond model is used to simulate the lighting effects in studio. In studio, we'll be having focus light and we'll be having light from more than one light sources. Right, if I want to simulate all these lights in studio, I can use this bond model. Right, and when the light from the point light source travels through the space, there will be attenuation in its amplitude. So while writing the intensity of specular reflection, I have to consider this attenuation also. Right, I have to consider this attenuation. So I'll write a quadratic attenuation formula. This is quadratic attenuation formula. And this FD I have to include in the final Pohm equation. Right, I is equal to Ka Ia plus sigma. This is for n number of light sources. This FD is the attenuation factor. Right, and this is my diffuse equation plus my specular equation. This is the final Pohm equation for specular reflection. Thank you.